Let's go through LeetCode code 823, binary tree with factors. For this question, it gives us an integer array, ARR, and ask how many binary tree we can make. So we need to make a binary tree using these numbers, and also this number, they can be used multiple times. You say that we need to make such a tree that each node of the value should be equal to the product of the value of its child. Let's take a look at an example. So we have an array 2 and 4. So we'll see it can make a binary tree with node 2, and it can make a binary tree with node 4. And also it can make a binary tree with 4 and 2, right? So it uses these 2 twice, right? So the result is 3. And let's look at the second example, 2, 4, 5, 10. So we'll see for each node 2, 4, 5, 10, right? So there are 4 trees here. And also we know 4, 2, 2 is a tree, right? And also if we use 2 and 5 and 10, right? We can have 10, 2, and 5, and also 10, 5, 2. So that means if we have, let's look at the features for this array. If we have 2 and 4, 2 and 5, they can be multiple and equal to 10, right? So we'll say this the tree node end with 10 is the number end with 2 multiple by the number end by 5, right? And because it can be 2 can be left child, and 5 can be left child. So if these 2 numbers, they are different, so the numbers end with 10 will be the number end with 2 multiplied by number end with 5 multiplied by 2, right? So if 4, let's say it can be write as 2 multiplied by 2. So the number of nodes end with 4 will be the number of nodes 2 multiplied by number of nodes 2, right? So if this number doesn't equal, we have a parameter 2 because we can swap left and right. So what we're thinking about is that because the tree we'll see the range. The range is that the array is greater equal to 2, right? So we'll say we'll see if we want to find how many trees to compose. We'll see the parent nodes. Well, if we want to have the condition, the parents will be equal its child products, right? Definitely right, child products. The parent nodes will always be greater than the child node value. So intuitively, what I'm thinking about is we sort the array first. and from each child, we try to compute its parents from the number of its child's and with its child's node tree to compute to its parents the number and with, for example, and with 4, how many number of trees here, right? So what we're thinking about is that we sort this array, right? So we have an DP. It can be int, right? Int, because this number it let us to mod, right? So let's use long, and we convert to int. So DPI in this case it represent the trees and root the with ith value, the number of trees we compose. For example, the DP0 is 1, right? And we know this DP4, DP1, right? It is 3, right? And DP2 is 1, right? And DP3 is 10. Sorry, this is 1. DP10 is also 3, right? It's also 3. So end with 10. It will be 10. And with 4, sorry, this is not 3, this is 2, right? So we'll see. Let's go through this again. So the trees end with 2 is 2, and the trees end with 4, that is 4, and 4 to 2, right? So there are 2. So the tree end with 5 is 1, and the tree end with 10 is these 2, right? 3. So the final result is 1 plus 2 plus 1 plus 3, right? So that equal to 7. So we use DPI will represent the number of trees we compose for the node end with the array I. So for this question, what we're thinking about is that we use DP compose from the left to right, from its child to its parents. And when we iterate, we sort this array. The first step is first sort this array. And the second is that we compose the DPI. We iterate I, right? We iterate I, and then find for every I, we iterate j from 0 to I minus 1, right? What we're trying to see if this array I is divisible by array j, right? If it is divisible by array j, and also if array I divided by array j, it exists in this array, then we can contribute to this array I, right? So if this exists, how can we find if array I divided by array j exists in the previous iteration? What intuitively what we think about, possible we can use 2 for loops, right? But the thing is that we have we can use a map, right? Map. For this question, it have another condition is that all of the values of array are unique. So what we're thinking about is that we use map. The key we save in the map is the array I, and the value will be the index, right? So So if we iterate I, then we use a for loop J, right? Trying to see if the map contains key array I divided by array J, right? And this is in the condition array I is divisible by array J, right? And if map contains, then we'll say if we have array K, then we'll say array J and array K, they contribute to array I. Okay, so we think about use a map. And for array J, do we need to iterate from 0 to array I minus 1? Actually, we don't, right? So we just need to iterate to square root of array I, because if we divide, if we divide, right? So we just need to iterate square root of I, right? In this case, we have for loop I is from 0 to n, and for every I, it will have a square root iterations, right? So the total time complexity will be n square root n. Okay, so let's begin to write code for this. We are going to use a private static int final static int, because we want mod, right? Mod equals 1. So what we think about is that we need to sort the array as we discussed, because the parents will always be greater than its child. And let's have int n equals array dot length. And we're going to have a long, we call dp, right? dp is new long. And so dpi will represent, let's write the counts of binary tree root with array I. That's because every array for every number, right? It can create a tree. It's just a one node tree, right? So let's have array dp as 1l. We are use a map. The key will be the array number, array I, or those kind of values, right? The value will be its index. We are doing this because for every array I, we trying to iterate array J, right? And also we if array I is divisible by array J, and array I when we have array K is array I divided by array J, we can use this map to get a case index in O1 time complexity. So for I, we iterate. What we are going to do is that for I, we're going to have I equals 1, right? I smaller than n, I plus plus. So we put because for every I, what we do is that we need to map put array I and I, right? And also, so in this case, let's put array 0, 0. Okay. So what we do is that we iterate j, right? Use that for int j equals 0, j array. We know this array j multiple by array j smaller equal to, because we just need to iterate those kind of j which have the square root of array I, right? Array I and j plus plus. So we'll say if array I mod array j equals 0, if array I is divisible by array j, right? And let's have a value. So let's have int value equals array I divided by array j. So let's check in the map if we have a key value v here, right? So if map contains key v, so we'll say we'll have an int k equals map get v. So there is array k and array j. They are going to contribute to array I, right? So, but the thing is that we want to see if this array k and array j, they are equal or not, right? So because, for example, 2 and 2, they contribute 4, right? So if this kind of k and j, they are put into a same index, they just need to, so this kind of array I will only be, will only add array j multiplied by array j. So we'll not have 2 here, right? So what we do is that we use a p variable here. So we'll say if p equals int t equals if k equals j, right? So that means we are going to just multiply by 1. Otherwise, we multiply by 2. So we are going to have dpi equals dpi plus dpj multiplied by dpk, and we have a mod, right? And we have a p, right? If array I and array j, they are not the same number, p will be 2, right? Because we can have either array array j as left child or array k as left child. So for every array dpi, right? So we finish the calculation of array I. Actually, we need what? We need a final result. Long result equals 0 L, right? Actually, the thing is that we should be 1 L because array 0 we didn't calculate, right? We are iterating from array 1. So the first node is also a tree, right? So we have result equals result plus dpi and mod, right? In the end, we return int result. So the time complexity will be O(n) square root n, right? Because j, we don't need to iterate from 0 to I, right? We just need to iterate from 0 to square root I. We can also also turn this one into Python. In Python, we cannot have a J, array J, this kind of for loop, right? So what we do is that for J in range I, we'll say if something array J multiplied by array J is smaller or equal to array I will break, right, like that. So let's convert to Python. So we also need to sort this array, right? Array sort. And we are going to have mod, right? We need to have mod. And mapping is the map, right? Map which have the array I and in as a key and index as a value. And the result will be our final result. So we'll see the mod will be 10 plus 7, right? And the length of array and the mapping will be map the key, right? Because the things that as we remember a moment ago, for our map, for our index I, we iterate from 1. So the map we need to add the first record array 0, and the value will be 0, index, and also the result should be 1, right? Because the first node we also need to calculate that. And we have a dp equals let's have this one multiply n, right? So what we do is the for I in range 1 to n, for j in range I. So here what we do is that because remember in Java we write for j equals 0, array j multiplied by array j is smaller or equal to array I. So what we write is that if array j multiplied by array j greater than array I, we just break, right? Break. And then we write if array I mod array j equals 0, right? That is divisible. So I say v equals array I divided by array j. So I say if v in mapping will have k equals mapping get v. And we'll say we'll have a p, right? P as a we'll say we'll have a p here, right? So we'll say dpi equals dpi plus p multiplied by dp j multiplied by dp k and mod mod, right? So that's the things that this p will be if j and k they are equal, p will be 1. They are not equal, then will be 2, right? So p will write like p equals 1 if j equals k, else 2, right? Right, like this. So this so after this we have result equals result plus dpi mod. And we also need to have this mappings, have array I and I, put that into the mapping, mapping array I equals I, right? In the end, we return result